Good afternoon and welcome to today's session of 6950. So for the last several lectures, we've been talking about Python as a language. And so I want to start off today by having a little conversation about that language for a moment. And then we'll roll into taking a look at what we called assignment 5, which was the exercises from chapter 2 of that. I already tagged a little bit earlier two of you to sort of say, are you around today? So I'm gonna pick on you if that's okay. So Karina and Prithvi, help me with the pronunciation if I got that wrong or right around. Do you have microphones and like cameras and that kind of stuff?
Yeah,
I have.
Yeah. So how about you turn those on because we're gonna have a chat and I'm just taking a look through my notes here. Who else is? There's one person. There's two person. Hello there. Thank you very much. And I'm just trying to find someone who has yet not spoken. So is there anyone else in this call who has not yet talked on the group? I wanted Atea because I had asked talked to her over Zoom as well, but I don't see her here.
Hi, James. Maybe I can join.
Levon, you're going to be able to join?
Yeah, sure. I'll join.
Sure, no problem. Excellent. Okay, so the three of you can serve as our little Python panel for a moment. I said we'll talk about Python as a language for a little bit, and then we can just review the previous assignment because I know you've all done it. Okay, so my first question for the three of you: imagine you're sort of in a conference and you represent. You're a panel. You've been chosen to give answers. What I'm looking for is a little bit of your own background with programming in general, but also your opinions on Python as a language, as in a language for science. So just just we'll go around. What's your background? Where are you coming from, and what do you feel about Python so far?
Can I go first?
Sure, Karina. Thank you.
Yes. Okay. First, I'm materials engineer, so I have learned 7 years ago C++, but I don't recall anything. Basically, I have actually noticed now with Python learning. And about Python, for me, I'm kind of relearn everything. I'm just getting comfortable. I'm in the process of getting comfortable with the language. So I have to go back all the time the documentation, how to do that, because for example, in this assignment has a lot, has dictionary, has set, has list, and try to get all of them are different syntax. So for me, I need to check all the time. And so for me, I am interested to learn Python because I know how powerful it is. For me, I'm graphical user. For me, it's easier, definitely. But when it comes to thinking my project, I know Python would be interesting because I have a large amount of data. So if I would have a smaller one, it would be easier to use Windows. But I know my files, text files has, I don't know, distance, energy. So I know to look what I want, the range of what I want, what I want to get as a result would be easier to use in program. I've noticed it would save a lot of time if I have learned before.
Okay, very good. Thanks very much, Karina. So we just said initial thoughts of
course,
of where we are. So we'll just go to the next person on our panel.
Hello, I'll go next.
Sure, thank you.
So my name is Prithvi. So I have a bit of experience on Python before. So I worked as a data engineer for a couple of years before starting my master's in computer science. So I basically worked on Oracle and cloud databases, AWS Redshift and Snowflake and all. And also I have a bit of experience. I worked on a year on Apache Spark. So I know a bit of Scala too. So yeah, so right now, so this is like I'm kind of revising what I already, relearning what I already know. Yeah, so that was my experience.
Okay, so I've got a question for you then, because you have recent and prior experiences with other languages. Like, so let's just talk about
Right.
Scala or Java or anything ones. What's your opinion on white space as a syntactical element in Python? There's no semicolons, there's no brackets, we use white space. What's your thoughts on that in comparison to other languages?
So I think in Scala also we do not use semicolon. I mean we can, but it is optional. So I think Python is all about, we need to use as much few keystrokes as possible. So I like it actually. So when I go back to Java, so I sometimes I get headaches reading those lines of code. It is very verbose. So Python is very convenient, and I actually like it much better than others. But Scala is also kind of like Python. I mean, it's much more higher level. I mean, it's built on top of Java. Yeah.
Yeah, no, that makes a lot of sense. I agree with you. When I go back and try and read Java code, there's so many lines that don't do anything, right? You just need all this text, and you're like, well, what does that actually do? And you're like, well, it does one thing. It's a lot of boilerplate, and Python cuts through that.
Yes.
Okay, fantastic. Levon, you were going to be the third person on our little panel. Do you have a camera today?
Yeah, sure, but I think my room is kind of missed.
Oh, sorry. It's just, it's always nice people to see faces. Yeah. Can always put up you gotta use one of those fancy backgrounds, right? You can.
That's what I'm going to do.
Oh, there you go. There you go. See, you can use technology. Hey.
Nice to see you back.
Yeah, good to see you too. So what are your thoughts of Python as a language, and what's your experience with programming languages in general?
Sure. So I did my bachelor's in electrical and electronic engineering. So in that case, I started the Python for image processing. It was a long time back. So that time it wasn't that famous. But now I'm doing master's in computer science. But I can see here, even the industry, Python is kind of used in wide area. It's like we can use Python for any purposes, everywhere. Machine learning, data science, data visualization, web development. So I think it's kind of fantastic language for use. But when it comes to a kind of machine-related programming like embedded systems or robotics, Python won't be that much convenient language in terms of speed. So it's kind of abstracted language, I would say. So rather than that, I would say it's a great thing, great language to learn, easy to learn. It's good for beginners. That's my opinion about Python.
Okay, so let's take that last sentence you had about good for beginners, and I'm going to rotate back to Karina. So thinking 7 years back to when you were doing an undergraduate in engineering, and you had to do a course in C++. Do you think it would have been better if you'd done Python originally, or did C++ serve a need in that first year class? Or maybe she's disappeared.
It's kind of frozen.
Oh, we lost her. Okay, I can't ask that question about her C++ experience. Okay, well let's talk about, Levon, your comment on what Python is not good for. So why is it not good for embedded programming or robotics?
Well, I would say about the speed, how it is executed. When it comes to a time-influenced application, time-sensitive application, if you want to generate kind of pulse width modulation or to receive that kind of things, Python would take much time to process it. But if you go with a C or assembly, that will be like a fraction of seconds.
Well, I agree with you that Python is not a real-time language, right? So if we're doing with real-time programming, and I don't know what your background is for everyone, but real-time is not that a program is necessarily fast or slow. It's just it's guaranteed that every instruction will occur suitably fast, right? So that you can do things. So you don't actually need raw speed. What you do need is that guarantee. You know how we're using Zoom right now? and it mostly works, but once in a while it doesn't, and Karina drops off and comes back and joins us again. You can't have that happening if you're doing the braking system of a car where it goes, you know what, I wasn't going to work today. You need to always work, and that's the redundancy isn't in Python. Actually, Karina, we had a question for you just as you disappeared. Thinking back to your earlier training in C++, and now having done some things in Python, what are your opinions as Python as a beginner's language? Is Python a better language to learn when you're learning about programming, or was C++ still the right thing to learn?
To be honest, I don't recall at all of the programming language of C++, but with the structure that I have set up here, I taught us with the one side, I have the tutorial, and the other one with the IDE interface.
IDE.
Yes,
Yeah.
exactly. It helps a lot when you get an error, and I think is easy to go through the tutorial so far.
Okay, that makes sense. You had said in your introduction that you're doing material engineering right now, and
No,
you're in
my background.
no background with material engineering, but your current
Yeah,
project.
but now
okay.
Is my current project pharmaceutical science.
Okay, so you had said that you were concerned that if you were to do it in Windows, it might be slow, and you got a lot of data. I guess I wanted to just clarify that Python's actually used probably even more on Windows than it is in Linux. In terms of who uses it, right? So Python, is open source, right? So who do you think pays for the development?
I have no idea.
Okay, we'll just go. You worked in as a data engineer. You worked with these open source tools. Who actually pays the bills?
Actually, oh yes, please.
Yeah, go on.
No, I'm asking you.
For me,
either one doesn't matter. Yep.
For me, I not have much contact with on course with C++. The rest of my course is basically research, but not using computer science tools. It's more like wet chemistry, so I don't have a lot of background. Now I'm doing computational experiments. Before it was like wet lab.
Right.
But in my I don't know who pays for that. I know it's free, Python, but who pays for that?
Well, it is open source, so some people do donate their time, but you don't get that many millions of lines of code written just for free. So who supports the developers behind these projects?
It's everybody. So it can be you or I. So we can it's open source, so we can contribute to that. So many hundreds of people contribute to this Python project every year, I guess.
You're right. It is open source, but you're all students, right? You are right now taking this course, maybe another course, and trying to do your thesis. Do you have time in your day or your week to spend 8, 12, 50 hours on open source software development?
No, definitely not.
Very few people do. So the reality is, though you are right, anybody can contribute to these things. These projects, not just Python, but you talked about Spark or anything else in the Apache toolchain. A lot of those tools, the core developers have someone who is sponsoring them. There's someone who's paying them a paycheck to do that development, right? So those individuals may be employed by companies, and part of their time is to work on this open source, or they could have some sort of other remuneration because it adds to the business case. So I would say that in Python, we're getting a lot of benefit from it in various branches of science, but I would say its use in finance is what's paying a lot of the bills. So data science and finance, right? So marketing, business logic, stocks and trading, analytics. There's money. right? People earn a lot of money behind it. And so if a company can build a tool or support a tool to do it, it just turns out that these business applications have a lot of great spin-off for science users as well. But I'm trying to get to this comment, Karina, you made about Windows versus Python. Most of these groups, these large banks, they don't run Linux on their desktops. They're all Windows enterprises, right? They have large Windows installations. So there's a lot of resources for running Python actually on Windows machines.
Yes.
Right. So you're not limited to that. That Linux on the server for sure, but on the desktop, Windows still wins in enterprise on the desktop. So that's all,
Sorry,
all there.
What I meant was I use Linux machine at my lab. However, I'm not aware how to do a program that could do things faster for me. So I need to know how to do a program inside of Linux or how to use Python basically.
Right.
With the
yeah, no, I understand that. I'm pointing out to you and the rest of the group that
yes,
if you ever encounter someone else who's in a Windows environment, you don't need Linux to use Python. It's a language and it runs on all sorts of major operating systems one way or the other. Let's see. Okay, we'll just, I don't know who's going to answer this question. Let's just talk about tool chains for a moment. You've all got different levels of experience in software development. So as you were doing the exercises for chapter 2, what I called assignment 5, what were you using? What was physically in front of you as you typed and clicked and did what you were doing? What kind of tools were you using?
I've been using just the VS Code and sometimes referring to the documentation or Google, but it's primarily the tutorial itself and VS Code. Yeah. And I'm using the terminal inside VS Code.
Did you try getting any of the debugging to work with VS Code?
I actually tried, but I don't know, for some reason I could not get it to work. I tried the breakpoint. I think I need to set the the file path. I mean, we are reading a file, right? So I'm getting that file not found error. So I need to figure it out.
Okay, no
I need
problem.
to figure out how to set the path. Yeah.
Sounds good. Just going along. Who's next? Karina, did you have a comment? How are you using the tools in front of you? What are you actually typing into?
Is also Visual Studio Code and a terminal below with the SW. I'm not sure the name, the terminology.
VS Code,
but
so Visual Studio Code is what it's called.
But with the terminal that was W2SW something
WSL,
like that.
Windows Subsystem for Linux. Yeah.
Yes.
Lot of acronyms. Okay, so that tool, VS Code, it isn't only for Python, right? You can use it for lots of languages. JavaScript, TypeScript, C++, and in fact, and there's a lot of other tools out there that are integrated development environments. And so if you're doing development in Windows, like Visual Studio is the go-to tool. If you're doing something on developing for an iPhone, you're developing the next app, you probably are using Xcode as your development environment. And there's equivalent ones for Android and all the way through. But that's good to be aware of it. Levon, what type of interface are you using to do your Python programming?
I'm simply using Nano.
Ah, you're a Nano user. You're just doing a pure command line. No IntelliScript, no variable lookups.
No, I think I can manage with Nano for these assignments.
Okay, and is that partly just a personal challenge you've given to yourself, trying to do it?
Exactly.
Okay.
Yeah.
Okay. Nano. Huh. Okay, good for you. I find Nano to be a bit limiting. I use VI or VS Code or other Python editors. 10. Anyways,
Well, I have used VI earlier, so this time I just wanted to try with Nano. Nano is totally new to me.
Okay, so this is you're trying to learn something, which is why you're doing it that
That's
way.
right.
That makes a lot of sense. Cool. Well, thanks very much, all three of you. Now I'm gonna flip gears here, and I'm going to take this, and we're going to talk about just the exercises in from the previous chapter. So chapter 2. So basically in these chapters, we were working on two different problems, pcost.py and report.py, right? So I don't know how many questions that there are, so we'll do this relatively quickly. So Karina, I'm wondering, is it easy for you to? I'm wondering if I should share a screen. I'm wondering if that's going to be easier, just to sort of keep us together.
You or I?
Yeah, I'll share a screen and ask you just
Okay.
a bit about your own code. And then I can sort of flip between you without having to do screen changes. Okay, so one of the things we've been using, of course, is GitHub, so that I can sort of see what you've been doing, and I can load up other people as well here fairly easily, and I'll just do that. Practical Python. I'm trying to remember. There you are. There's Levon. Okay, so we go in here, and you've all forked this, and the idea here of it, and I'm bringing this up because some people didn't quite get it, is we've all started from the same original repository, and you forked it, and the point is we all start with the same base, but I can see here in your commits what you have done. Okay, and partly I've tapped you because something popped up in my thread a few hours ago, and I go, aha, here's someone who's completed the assignments, so I know you're done them. And you can see this history, and we have a history of every time that you've done an exercise, you've made some change to it. So let's just go through some of these changes and just talk about what we see. I'll go for you for a while, then I'll switch to somebody else. So exercise 2.4, this was what your code actually looked like in this point. So what you did is you started working on report, and this is what you added. So I can sort of see in one go what's inside this script. Okay, so do you remember what read portfolio was supposed to do?
This 2.4.
Yeah.
First is, I think it's just print. Below there is a print. It's not printing anything here.
Oh, you know what? I'm looking.
First, I have the.
Yeah. So this is just your original one. So this code, you're importing a CSV, and then you define a portfolio. So what's missing in this?
I don't believe there is no print here, but I think I have done this again, commit again, because there was a kind of an error. I've not printed anything. I need to return portfolio, but
right
there's nothing in the screen. So, yes.
Okay. So I'm pointing this out as an excellent commit message, right? It's not that you just said exercise 2.4, exercise 2.4.
Oh, yeah.
You said, okay, what's the difference between these two things? This tells me that this is the commit that has the print. And in fact, there's probably some other change you have here to get between the final one. So if I'm looking at this, I probably want to jump to this version of the code
Yes.
to actually see what it looks like. So there is what the code looks like. And I'll do it in a
Oh,
right, that version
I remember
of it.
that as well.
Yeah. So you need another fix. So this is good. This is why we look at the code this way. So there's the entire program, right? So there's your import. And so my question to you is what does this program do? Do you remember what it did?
Just print the total of this portfolio, the total cost, I believe.
Okay, so
share versus price. Yeah.
Well, it did two things though, right? So it computes the total, right? But
Yes.
and then it prints that out, but it does something else.
For me, I set up this last here because I was not I didn't want to type my in the prompt. I want to open the portfolio because there is then something with dash I. So for me, it was easy just to declare portfolio is equal to read portfolio. So it's gonna run right away instead of print it. So
So my only
for me,
comment,
it's just gonna
about
yeah,
this
please.
code as written, and you might have changed it in future
Yes.
versions, is this code depends upon this portfolio thing, right?
Yes.
And your whole function is returning portfolio. So I think it
Yes.
makes more sense to take this block of code
Report.
and actually move it down to here,
Yes. Down, not inside of
not inside, because it
the
returns
for.
portfolio,
Oh,
and
okay,
then you can use
now I
it.
got it.
Yeah,
There's two fors. Yes, that's true.
yeah.
So return
So
portfolio for the first one in the yes, I
yeah,
agree.
no problem. So
Okay, two fors.
that's excellent. Okay, let's pick someone else here, and we'll just go in through and see what they're doing. So there we go. I got your thing set up, and let's go to exercise 2.4 and see if there's any differences. Okay. So you did one difference here. You have something slightly different in terms of how you're running it. So what does that mean?
So basically, we'll be reading. I mean, if a command line argument is provided, if the file name to read is provided, then we'll read that file. So the 23rd line will do that. So if a file name is not provided, then we'll read the data portfolio, which is the default that I've set here.
So I like that in terms of testing, in the sense that you've got a sensible default. So someone just runs the script, you get something, but you have the option of doing something else. Other than that, I think the program is basically exactly the same as everyone else's. Let's just check Levon's real quick to see if he's the same. And so all I'm doing is I'm going back and I'm taking a look at your history, and then taking a look at what the program looks like as of exercise 2.4. Okay, and so for Levon's, he just has the raw code and nothing to test it. So now we can ask that question to Levon. When you were doing this code, now you have to think back to exercise 2.4. How did you test this program? You're muted.
Yeah. Well, I tested this program in Python interactive mode.
Okay.
What was asked in the exercise instruction, I guess. So I have to run this program in Python interactive mode, and I have to call the function and pass the file name inside the function.
Okay, so you ran Python and then loaded this script?
That's right.
Aha, okay, so, yeah.
It was asked in the exercise.
Oh, no, that's totally fine. It's just what I'm noticing is 3 different ways of doing it, right? So Karina, what you did is you wrote it so that it would hard code it. Levon, not Levon, Priva, you put in a file name argument. Levon did it straight through. So there are different ways of doing it. The core of the actual assignment, of course, is just this bit to create this file. That's the answer, but you tackled it in different ways. Someone, uh-oh, what did I do? I clicked the button too quickly, and now I don't know what I'm doing. Zoom. I just clicked a button accidentally that was going to show me the chat. So someone sent me a message on chat, and as I tried to click the button, I hid it, and I don't know how I did that. So if there's someone who's online who sent me a chat, if you want to put that on Slack so I can see it, that'd be great. Okay, let's continue on. Let's continue on to talk about these things. And so we'll go back. We'll take a look at the history. So 2.4 was basically cranking up with this initial script that was going to give you the structure with it. And then we had to go on and we had to work on report.py. So I think that was what was called exercise 2.7. And what I'll do here is just, for each 3 of you, we'll just find what exercise 2.7 looked like. Nope, too far back, forward, practical Python, work, history. Oh, you did it all in one go. No problem. Okay, so no, I don't want the history of it. I want to see the file. I want to see the file. Computer. Yeah. Okay. So this is good. So this is the report for it. No, that's 2.7. I don't want 2.7. I want the exercise here. I'm looking at the wrong person. That's why I'm confused. That's why I'm confused. So this is your exercise 2.7. Okay, so Karina, what has changed in this version of the program? So I'll unsplit it so you can sort of see what it used to look like and what it now looks like. Okay, so this, whatever the question was, the code used to have these lines in it, and now it has these lines. So the actual program is exactly the same.
Yes.
Yes. And then what have you added to it?
It's down now, so could you just scroll up a little bit? No, scroll down a little bit.
Yeah,
just
yeah.
to
So you
remember.
have your read portfolio, which we talked about.
I think the second is just trying to skip the blanket. Yes. I think it's 2.6, just try to skip the blanket lines, right?
Okay, so you tried to skip the blank line. So what line number skips the blank lines?
Sorry, I'm not sure if my internet is unstable or because it's just kind of cut off.
You're only seeing part of the screen?
No, yeah, no, now it's back.
Okay, weird.
So here I have seen that to try to skip the blank lines and return only in the dictionary, because I want now to read the price of the current price, not only the cost. And after I have printed just to check what the price are. And below I have done the 2 fors for calculated the total before, it means the cost of the stocks, and after it's the current value, current amount of money of the cost.
Okay.
Not the cost, the stocks, basically.
I understand.
And
okay.
And then see the cost.
And then you print out the difference. Okay, so a couple comments here. Is this the code that decides if the line is empty or not? If there's missing data?
Yes, with the pass.
Okay, so that the pass is good.
Yes.
But whenever you're writing code, and I think you've solved it fine. This is great. You're going to get this error because row doesn't have a first part and a second part. But this is a great place to put a comment saying, and like just put the comment right in there saying skipping a blank line.
Oh, yes.
Because otherwise someone else comes to this and is like, well, why did you do this?
What?
Right?
Okay,
why? Like, because it's
yes.
not obvious. So that's where you use comments to put that all the way in. And the only other thing I would say about here is you've got 2 loops, right? You're looping through everything. You're doing 2 loops. You could actually do 1 loop, right? In 1 loop, you could do this and this. It doesn't really matter, but you could. Okay, that's fantastic. Let's see how this one changes things. Oh, okay. So you have a slight, here we go. Here's a little bit different code. So this is Pridvaz code. You went with a different issue here. What were you checking for as you read through? You didn't use a, you put a value error here and an index error here. Is it possible to get a value error here?
I actually got this. I mean, And I mean, when I ran, there is one file, I think it's missing value, missing.csv or some other file. When I ran it, I got this index error. So I just, copy pasted that index error and put it in here. So I guess I'm not sure exactly if we'll get value error or not.
Right. So when you had the test data, you generated a value error, and the value error occurred because it tried to turn something which wasn't a number into a number.
Right.
Here,
yeah.
Here
Now,
the problem
now I got it.
was the value was just missing, and so when it tried to read it in, it got a different error. So there's another way of handling these things. Rather than saying accept value error or accept index error, if you wanted to, you could just put an accept and get rid of that entirely.
Right.
Right. Either one of those things is just fine in terms of doing it. And other than that,
but again,
yep.
This is one of the problems that when so we should not. We were advised not to do that when I was working, because if you are getting some other error, you will be suppressing that. So if you have to do that, so first you need to put the index error, and then you need to put the accept, I guess. So the first, this will, if an index error is occur,
I totally respect that opinion. Okay, no, that's good as well. I agree. If you had a general error, you'd still want to propagate that up, right, and explain.
Yes.
Otherwise, the user wouldn't know it. If you just passed on every error, you wouldn't know what the problem was. No, I get that. That makes a lot of sense. And other than that, the code looks exactly the same. And Levon, did you do anything different? Oh, this is again exercise 2.4. I don't have a great way of going to the next file. I know how to go to the previous bit of the history. I don't know in GitHub how to go to the next one in the history. But let's just take a look here at this change. We'll see if your code has anything different. Oh, you have some testing now, Levon. You went from having no testing to having this. Well, this is interesting. This is very interesting to me. Okay, so this is a different solution than the other two. Okay, so I agree that in this program you've got up here the same basic functions. You have a read portfolio function, and you have a read prices function that does whatever it does. But you've solved the main problem a bit differently than the other two. So could you just talk about what your main program does? What does this block of code do?
Well, it's gonna read both files in first 47 and 48 line, and it's gonna create an initiated directory file, and I'm going to read the portfolio file to get the contents out of it. That means the name, share, and price. That's the for loop. And I'm going to calculate the current value. That's what I need. I need a current value and old value for the shares. And what I have done. And I'm going to check whether it's a gain or loss. That's why I'm using the if condition.
Okay.
And I'm printing the results.
And you're printing the results. So you had a dictionary. Sorry,
that's right.
This was a dictionary. And then you made a new dictionary. Okay, so two comments about this. You already had a dictionary. This field is the same. This field is the same. It's really only the current. I'm trying to figure out what's when you add current portfolio. It's really just current value and status is what you're adding to it. So another way of doing this would have just to have, instead of this line, have portfolio opens portfolio, I guess, of n, square brackets, current value equals current value, and portfolio of status equals status. Right, and then you didn't have to copy the data. Because right now you have two copies of the data floating around. So current portfolio is sort of disconnected from portfolio. So you could add keys to it. So that would be my one suggestion. But that's sort of minor. The more serious one is, now maybe you wrote this a few days ago. How would you refactor this knowing more about how Python is supposed to be done? Because that is not Python code. It is Python code, but it's not very Pythonic. Why am I saying it's not very Pythonic?
Because if I'm using this for this purpose, instead of that, I can use, I saw that in exercise.
Yep.
Enumerator, I guess.
We don't even need a numerator, because if you look through this thing, you're always talking about portfolio n, portfolio n, portfolio n, and that's the only time you use n. So what you can do is you can say for portfolio item in portfolio.
Right. I don't have to index it yet.
Okay. So this tells me you are a programmer in other languages, because in other languages you have to do that. But this is one of those common things where you recognize someone came from another language. But that's a good example. So we're not going to do that. We're gonna clean it up. Okay, we'll do one last one, and then we'll move on to something new. We'll go backwards. We'll start with Levan, and we'll go the other direction. Let's just take a look here at this exercise 2.16. So this is one where we've continued to modify report. So I'll just add in all the other sections. So it has a read portfolio section, which we've seen before. Oh, well, we seem to have lost a lot of stuff. Maybe it's all here. We just went through your read portfolio, and it had this wonderful main, and now it's all gone. I'm looking at Levan's code, right? What happened? What happened to your wonderful routines? Work? I'm gonna go and take a look at your latest version because I'm confused.
Sure.
Okay, we're just going to go with this version of it because this is your latest and greatest. So the big change in this one is what you've done is there's a few changes you made. One is read portfolio now has a different construct here, right? So rather than all of this, you've replaced it with this. So the first thing is you don't need to actually comment things out in code. It's all in the history. So when you delete it, delete it. If you don't want it to be there, get rid of it. But what does this actually do? What does dict zip headers row do in this program?
So in line 16, I'm going to get the headers, and for loop, I'm going to get each row. So when I use a zip, it's going to map the headers header key with the respective row value.
Okay.
So in case if I had, yeah.
Right. In the old code, in the previous commit, what you did is you handled int of row 1 and float of row 2. Haven't you lost that by doing it this way?
Not exactly. I'm going to have all the values here.
Well, no, because row is going to be a tuple for each column.
Yes.
A string, a string, and a string. So now this record is going to be a dictionary of strings. So you've lost the type conversion. Let's see how you actually use this code down here. So down here, you read in the portfolio, and then you're still using this Pythonic sort of way. Right here. You have to do the conversion. Right? So you pushed this low-level detail quite high in the code. So typically what we try and do is make these functions as useful as possible. So if it's expecting to read in a portfolio, that portfolio should have the right data types. You shouldn't have to do these translations high up in the code.
Right.
right? Cool. Okay, let's see how we'll go backwards. Let's see how someone else solved that issue. And we'll just do a comparison here. And this is all fine. This is good. This is what I'm expecting to see as variations. Okay, so we've got a portfolio. Oh, I love the doc string. I'm proud of you. Excellent. Very, very good. So here you didn't use a dict zip. You just appended each piece. Okay, that's fine.
Yes.
That's fine because you still need to handle the conversions all the way through. Can't remember. I thought exercise 2.16 required you to use a dict zip. Maybe it didn't. It doesn't matter to me. I like what you've done. You've got the portfolio, the prices, and the report. Let's talk about this section. What does this block of code do?
So this will print out the portfolio and the current the gain or loss of the a particular share. So it will format it into a table.
Right. Okay. And so what does this thing do?
So what I've done is, so I've in line number 40, I've appended the headers in the first line as the first record. So that I'm popping. So this will remove that and put it into this header variable.
Okay. That makes sense. And then you iterate through them all, and
Yes.
you handle that a little bit differently. Okay. So the only other comment I have is this one.
Yes.
Why did you do a string around a price, comma 2?
So this was, I think, 2.17. So we need to, in that task, we need to have a dollar sign before the price. So for that, I've converted the price into a string so that I could append this dollar sign. And then in the next line below, I can put it in 10s. Yeah.
Okay. Why didn't you format the price with notation like that? What was the challenge you encountered?
The challenge was that if I did that, so I could not place the dollar sign next to the price value. So if the dollar sign, if I put it before this braces, so there was like gap between the dollar sign and the actual value. I could not figure out how to put it this way, so I
understand. I know exactly why you did this. I'm just commenting on the difference there. So there's another spot, because it's a little bit odd that a comment saying this ensures that the dollar sign is right beside the number.
Okay.
Would be useful. That's fantastic. Okay, let's just do one more here, and then we'll give this a rest, and I'll let you guys get off the hot seat. README report. Karina, I'm just going through yours. Is there anything here? Actually, you've done it the way that I was expecting. No, you didn't do it the way that I was expecting. So close. I think everything else is fine. Yes, everything else is fine. We're just going to talk about these few lines of code right here.
Yes.
Okay. So what's going on in line 16 through 22?
So I create a dictionary with a zip's gonna pair up both headers and row.
Yep.
So
nice.
I have a name value. With name value, I have the key and I have the value. So the first always going to be string. Is the second I have to convert to the proper type data that you have here. First a string, second integer, and the last one is a float. So it's gonna return this. Not return. It's first gonna append. It's gonna add each one if the three of them in the portfolio into the dictionary for construct the dictionary, then return the portfolio because it's a function.
Okay, so we read the headers in because when we run this program, we don't know how many columns there's going to be.
Yes.
Right, and headers allows us to figure out the columns sort of dynamically, right? It's saying, you know, it's going to be a dictionary, and every row is going to be indexed by the name of those headers.
Yes.
Okay, so you see on 16, you've got.
I'm not sure. Oh, sorry.
You
Yeah,
see on
please.
line 16, you did that.
Yes.
But when do you use record again? I'll make it big so you can see it.
No, I haven't used it because I'm declaring the dictionary to pair up and then name. No, I haven't used it.
You haven't used it. So you could delete this line and your program would run exactly the same.
Because I already zip. We don't need zip because I already pair up because I'm
So
declaring the name value.
this does the
Yes,
pairing up, which is good, right? But then you still did this. You'd have to do the pairing up again.
Yes, duplicated.
Duplicate it, exactly. So this does the pairing up. What do you still need to do though? There is something in this block of code that you need. You don't need to do the pairing up. What do you need to do?
I'm already calling the name value into the append.
Yeah, but you could just do append record.
It's not necessarily name value.
You don't need naming value at all. You have the record.
Because before I have declared already the int the float. Yes.
Yes, you do need to handle these two lines. And so the way that
Yes.
I would handle it is I would say record of shares equals int record of shares. Record of price equals float of record of price.
All right.
Okay. So
below the record. Okay.
Right, because this here, you're sort of losing the value of doing it up here.
The record.
Okay.
Yes.
So this is not just you, but generally across the class. Like it doesn't matter. If you've done these assignments, I'm giving you full marks. I don't care about the marks. But there's reasons for doing things certain ways. And what I wanted to do was talk about different structures like lists and sets and dictionaries, because this is how the language works. These are sort of the base pieces. Anyways, thank you very much. I appreciate it, the three of you. This is all good. If anyone else had questions about how to finish off this exercise, we can either talk about it after today's lecture or over Slack. Most of you have done it. I just was trying to get through all this kind of stuff. Okay, let's do something new. Okay, let's now I've lost. I've completely lost the you know the little bar when you share a screen, it says chat and participants and all that kind of stuff. It's gone. Completely gone. How did that happen? I'm just going to drop off the call and I will be right back. I can. I don't even know how to quit. What did I do?
If you click the view button in the top right, James, does that do anything? Is that in there?
I have no idea. I didn't know it was even possible to hide that little window that's always annoying, and I hit it, and then I couldn't bring it back. Anyways, well, that's fine. I just killed it. So let's just go to a screen. Okay, we'll just close. This up. We'll go to general at the top of the window. Yeah, there was no top of the window for me. It's bizarre. So they're all you, and I wanted to focus on this this screen right here. So I'm going to exit out of here. Clear. Okay. What I want to talk about now is some of the libraries that are in Python to make it more useful. So we've been talking about basic things like dictionaries, lists, variables, loops, which are in any kind of language. The value in Python isn't just its language, though it is expressive and low number of characters. Where people really get value from it is all the packages that are built into it. So one of those packages is something called Matplotlib. It's for the purposes of making plots and diagrams. So let me do two things. One is I'll just open up a terminal and show you what I mean by plots and graphs, because you do this all the time in science. Let's just go to examples. Examples is cool. Okay, so here are the kinds of things you typically want to do in any scientific context. You want to be able to make charts and graphs, right? Bar graphs, line graphs, area plots. You want to be able to modify colors, sizes, fonts. You want to be able to make things with contours, wind barbs. You want to be able to display images on your graphs. You want to be able to display multiple subpanels. You want to be able to do things with fancy axis zooms, right? So say you're doing a plot where you want to show a subset of two plots. There are a lot of things that any graphing package worth its salt will be able to do. So Matplotlib is the sort of most widely used static graphing plot in the Python world. There are other ones, but it's now been around long enough that it's sort of the library that others are compared to. And one way of discovering what it can do is just sort of browsing through these galleries and being like, well, I want a plot that looks a little bit like, well, this one. I want to make this plot because in my data, I've got a bunch of objects at certain points and I want to make this plot. Well, one way of doing that is you could take a look at the code and you could sort of copy and paste it and make it work. So I want to talk about Matplotlib as a library. So let me just get rid of this for a second. So how do I make it go? Okay, so here we go. We've been talking about Python, right? You run up Python. Now, if you have Matplotlib installed, here is the conventional way of loading in Matplotlib. So there's a library called Matplotlib, and there's an interface or what's called an API to it called PyPlot. And what we do is we import that library with the shortcut PLT. And that's just the convention of how everybody gets started using Matplotlib. And the way that Matplotlib works is you have basically lists of data, right? So you have some X data. Let's have data at 1, 2, 3, 4. So imagine those are some observations. And then I've got some Y data. I've got a 2, a 0, a 6, 5, and 3, okay? So there's another set of data, right? You load that in somehow. You might read it from a file. And then what you do is you use a command called plit.plot. So plit is the library representing all the Matplotlib functionality. And the sort of the basic thing you use is X, Y. That's the fundamental idea of plots in this library. You plot the horizontal versus the vertical, and you get something. Now, it's a programming language, so you don't automatically get something you can see on the screen. If you're just starting it from the low level Python environment and you do plit.plot, you'll get this expression that says Matplotlib lines line to the object. This is a data structure. It is something that represents this plot. If I was to take this file and save it into some temporary variable like my plot, I could continue to work with it. So my plot is of type list. It's actually a list of plots. Well, what the plot is all of the things that show on the figure. But if I actually want to see it, because what's good as a plot until I can see it, the way that Matplotlib works behind the scenes is you have to take that plot object, and save it somewhere and render it so you can see it. And so built into the language is the idea of taking that file and saving it as, say, a JPEG file. What? Oh, sorry. Plit.save fig. Myplot.jpg. I got to remember the syntax. Or you could save this file as a say a PDF, right? And what that will do is take the image you created and save it to the disk. Okay, well, so what does that mean? It means that if I go and I take a listing of all of these files, there is, in fact, 2 files I've made, a JPEG and a PDF, which is sitting in my downloads directory. So depending on what operating system you're looking at, you could say maybe open up a file explorer, and there is my plot. And that's rendered as an image. And you can see that there is a horizontal scale and a vertical scale. And what it's done is it's put a dot here, 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 and here. And if I was to open up a similar file as a PDF, this is another rendering of the same image. Now, Matplotlib, what it's doing is taking the idea, the concept of a bunch of lines, and turning it or rendering it into different visualizations. The visualization could be a raster file format like JPEGs. Raster is where each one of the pixels is resolved separately. All images, GIFs, PNGs, JPEGs, these are all examples of raster files. Think digital cameras, pixels. And if you zoom in to that image, you can see that things start to get a bit fuzzy. Okay, I'm not sure I can zoom in anymore, but nope, I don't want that. If I zoom into this thing, you can see the line starts to look a little bit fuzzy. The 2.0, those lines aren't super sharp. And that's because this image is actually just a bunch of pixels, and it's rendered at a certain resolution. And there are options in Matplotlib that you can say, I want to save this as a higher resolution raster image. There's another class of files, which are called vector images. So PDFs, PostScripts, SVGs. And the thing is with them is each one of the symbols that's actually in the document, I could zoom in as much as I like. And the quality is never going to go bad. And that's because what's saved inside this file is not a bunch of pixels, but actually a character. And the character is the character 5. And the character 5 is being rendered with a font. So you can zoom in this thing as much as you like and get no loss in quality. Likewise, these images like this, this spot right here that I've zoomed into, this is actually not a bunch of pixels. It is a line. And what's been rendered is actually a line with a round end cap. So the quality is very, very good. So Matplotlib, its purpose is to take an abstraction, an object representation of a bunch of graphical elements, and put them into something called a backend, whether it be a raster backend or a file backend, so you can see what you're looking at. So one way of using Matplotlib, and this is actually a real use case, this is what software does behind the scenes all the time, is you run some code with Matplot, import matplotlib.pyplot plot is PLT. You make some plot, right? Maybe you change the colors of it so it becomes a blue line with dots. Maybe you add in a label, X dimension, you add in a Y label, thing. You might add in a title. I don't know. Okay, so what we're doing is we're creating a plot, some labels, and a title, and all that together, plit.savefig can be rendered on plot2.pdf. I could render that out as a file, and then I can go look at it. And you see my great plot now has a few more details. It's got a title. I've changed the formatting along the side. Okay, so this is fine. This is a way of doing plots. If you wrote a script, a piece of Python code, at the end of the Python program, what you would do is have something like a save figure, and what gets produced by your script is a JPEG or a PDF that you can look at in a web browser. So that is one way of using these libraries, sort of an offline batch sort of way where you just run a program and it creates this plot. So I could take these lines, this line, this line, this line, this line, this line, and this line, put them all into a script file and run it, and that would work out just fine. The code is actually taking the plot and turning it into a raster image like this JPEG, or this thing which is a PDF, are called backends. And Matplotlib has a number of backends. Oh, RC setup. RC setup. Okay, so these are all the, at least on my system, ways that Matplotlib knows how to render something. It can render it according to a number of different graphical libraries. So GTK is a common one. Qt, Qt4 is another one. TK is another one. Cairo is another one. Ag is another one. WX. These are all different ways of rendering graphics to the screen. It also knows how to render things to disk. It can render files as PDF or PostScript or SVG. And Ag is actually the backend when you save something as a JPEG or a PNG. It's what it's using. Depending on what your file format is, it's going to choose one of these backends. But the one thing we don't have set up here is the ability of me to say, you know what, I really just want to see it. Now, if you're running this on Linux, not WSL, not the Windows subsystem for Linux, but actual Linux, like with X Windows, or you're running this on Mac OS 10, it's possible that when you say plick.show, it just works. If you've installed Python as a Windows application, it's probably been configured by the companies who are actually paid to bundle Python together so that this just works and you get a picture appear. If you are set up to use Windows subsystem for Linux, there's a little bit of like, well, I want a pretty picture to show up. Now, you can always save the image and then jump over to here, take a look at it, but that's not always convenient. When we're dealing with Python programming, when we're dealing with data analysis and science, sometimes what we want to do is we want to interactively work with the graphics and images that are appearing. And so what I want to do is switch gears from working with the terminal and working with text editors like VS Code or Nano to talk about something a little bit different. And the thing that I want to talk about that's a little bit different is called Jupyter. So if you're familiar with data science, you'll have heard of Jupyter. Jupyter is an interactive web-based interface to Python and R and Julia and a whole bunch of other languages. It's a way of interacting with your code and your data through the web browser. Now, you can go off, and if you were to do a search, okay, for the word Jupyter, okay, and now it's a little bit odd. Jupyter is spelt Jupyter. That stands for Julia, Python, and R, which are three languages that are sort of all supported by this among many others. It's got a weird sort of spelling. And you can click on it and you can find things like install, and there's documentation. I don't want you to do any of that. If you find you actually need a Jupyter installation, you probably want to download some distribution to have all this software we're in here. And so what I'm going to recommend is one of two things. For the purposes of this course, and there's lots of distributions. You might have heard of something called Anaconda or ETS. Those are fine. I am going to recommend, if you are we're doing things in the terminal, something called MiniForge as a way of getting Jupyter and all this graphical stuff onto your system. When we've been using Python up to this point, I'll just clear my thing here. The actual version of Python we've been using, whether it's Python or Python 3, is probably installed in the system. This is sort of a system level Python. If we want to add packages to it and we want to do graphics with it, we want to do more, we want a different version of Python to be installed. And the one that I'm going to recommend, and there's lots, is something called MiniForge if you're doing science stuff. Okay, so Miniforge here is a conda-based distribution of Python. And basically, I'll just drop this onto to Slack. There's a bunch of installers. And so the way that you would install this is if you're on your system and you wanted this functionality, you would download this package. Okay. And what I'm going to do here is I'm going to right click on it, copy the link. Okay. And I'm going to use a wget to download it. Okay. Because wget goes to the web and downloads a file. I don't know how fast my internet is here. Okay. I'm downloading it. I've already downloaded it before. And if you actually take a look at what the file is a shell script. Okay. And this is sort of a bit interesting. How can an executable be a shell script? Well, what they've done is they've actually put as the installer a bash shell script. And inside this file is all the commands to do the install. Now, it's a big file, okay? If you open this up in an editor, it's it goes on for a while. It goes on for many, many lines because most of the lines are actually, so there's the setup script, and then there is a bunch of code. Here, let's just go down to 2 lines. All this stuff, this is binary. This is the binary file. So if you want to run this, what you do is you say bash space miniforge.sh, and it gives you a little installer for what you're doing. So how do you install it? You review the license, you hit enter, hit space. Do I accept the license terms? Yes. Where do I want to install this? You can take the default, and then it goes and installs this thing, whatever this thing is. You can just take the defaults on your system. It's doing a bunch of stuff. Do you wish to initialize the installer? I'm going to suggest yes. Okay. And then it says for the changes to take effect, close and reopen your shell. Okay, I will close my shell and I will reopen my shell. And you'll see that what's happened here is now I've got this word base. If you type in conda info, you'll see that conda has been installed. And what conda is doing is it's using a version of Python inside this directory that's in your own personal system. So if you actually look up what version of Python you're running, you'll find out that it actually is no longer user bin Python. It's now this other one. And what this allows you to do is use a tool called conda to install things like Matplotlib. So if you wanted a package, you install it in this environment, which is inside your home directory. The advantage of using a tool like conda is you don't need administrator privileges to install software. So if you're working on another computer, something that doesn't have access to these libraries, you can install Miniforge without having admin access and be able to install it all. So that is one path. That is one way of getting Matplotlib and other libraries like NumPy and Jupyter and Pandas onto your system. And that's fine. And if you want to try that, no big deal. However, that's going to take some time to set up. Not everyone wants to download a whole bunch of things. We just want to get right into some stuff right away. So there are web-based implementations of all of this that lets you go off and interact with it right away. Omid, you said in Slack, you asked me, what about Google's Colab? Well, let's just talk about that for a second. Colab, the Colaboratory, is a research level product from Google that gives you an environment where I can have cells of Python and I can execute Python right in here in what's called a notebook. Oh, but to be able to run, I need to sign in with my Google account. Okay. Now, this is a Google product. They're using the Google sign-in. You have to have a Google account to use it. It is totally fine. You can, I guess, if you want to use it, that's not a problem. It allows you to do collaboration, but do remember this is tied tightly to the Google ecosystem. So you have to have a Google account. You have to be comfortable with sharing data with Google and everything else about that. Remember that anytime you're using social, any of these services which are free, if you're not paying any money, then you are the commodity, right? They're going to be getting some data from you somehow. It is an option. I'm not going to do this. I don't expect people to have Google accounts. But what's going on behind the scenes, the actual software that's making this work is Jupyter. Jupyter is the engine which is connecting connecting Python to what you're seeing on the screen. And Colab is Google's version of it. What I've done for you, or done for us, is I've actually installed, created, made my own version of Colaboratory that's hosted on the same computer that you all have accounts on. So if you go off to this website, and I'd like you to do this with me, what I've done is I've set it up so that if you have a GitHub account, okay, so if I go into like, oh, I've already logged in. I don't want to log in. Okay, I want to demonstrate the login. File, log out. Okay, so if we go to this page, you're going to get this link that says sign in with GitHub. Okay, that's your GitHub account, right? We've been using GitHub to submit assignments. It's the same thing. And what I'm doing in the code is I'm actually just asking GitHub to say, is this really the person who says who he or she is? And if I say get a yes, I create an account on my machine. So, and this is the Jupyter environment set up with a personalized account just for you. It's similar to Colab. It's just, this is an environment. And the reason I'm doing this is so that we all have access to something called a notebook. We all right away can say import matplotlib .pyplot as plit, import something. The fact that that's not working suggests the machine's under a bit of load, and I can say plit.plot 1, 2, 3. And my guess is a whole bunch of you have just tried to do this right now, and so my machine is getting bogged down as it tries to spin up 20 copies of this, which is fine, which is just fine. I am sure it will start to run in a moment as soon as it's not being loaded. Let's do this. Let's do a top. Yeah, there we go. I'm seeing other people trying to sign into this thing, which I'm sure is where the delay is occurring from. Okay, excellent. So in a Jupyter Notebook environment, you're able to execute lines of code and immediately see what they look like. And so if I wanted to modify my program, I could say, you know what, I want to plot that figure. I want to change the labels, X dimension, and then I can just rerun it and see right away what I'm looking at in terms of the feedback. Okay, so this is the environment that I've set up so that you're able to interact with Matplotlib, NumPy, and any other packages. I just know it will work for you. You don't have to use this. If you've got your own installation of Jupyter and you know how to use Conda, be my guest. You don't need to, but this is a nice way of getting the files, getting a common look and feel without us having to download a whole bunch of things to get us going. The way that it works, okay, is you've got on the left-hand side here, and you can close and open that. These are all the files in your directory. You should all, if you do this, and I encourage you to do this, have a directory called CMSC6950. Inside that directory, I've put a few starter files, okay? You don't have write access to those directories. You only have read access to those directories. So what you can do is you can make a copy of that file into your home directory. Okay. Now there's ways of doing interactively, but this is a computer, this is a remote system. You've got a terminal. So if you click on terminal, you get a terminal. And I can go in and do an ls, and this is all this bash stuff we were learning. If you go into this subdirectory, you will see some files. Those files are not are only read-only for you. So what you'd have to do is take those files and copy them to, say, the parent directory. Why can't you copy it? Permission denied. Why can't I copy? I can create files. They're my files. Can I open them? I can copy a file to a parent directory. Now I'm really confused. Is anyone doing this with me? Is anyone created? Some of you logged on. Let me just take a look at who's here. A few of you have done it. Oh, no. Sudo will definitely work. I don't want sudo. I want you to be able to do this into your own shell. I want to make a copy of it. Why can't we copy? So, Brad, have you actually tried this? No, you haven't tried this. Vivek or Mike or Karina, are you able to actually copy a file from a CMC directory into your main directory? I can create files. I can open files, but I can't seem to copy a file. Why not? Copy.
I'm trying to do it now, James. For some reason, it's not letting me open the terminal. I'm trying to mess around with it.
Okay, there is something that's not configured exactly correct, but I will show you this. Okay, so if you go into that directory and you right-click on something and you hit copy, and then you go to the parent directory, you can hit paste. And that worked. I am completely at a loss why copy isn't working. That I'd have to figure that one out. I have no idea why that's not working. But this works. This is good. Okay, so Karina, if you try, I'm just trying to make sure it works for some people. If you go into this directory, you right-click on it, you hit copy, and then you right-click out here and hit paste. Do you get a copy of the file? I'm waiting for anybody to give me a positive confirmation we're doing this right. Paste error. It just says paste error. Why is it giving me paste errors? This is where audio feedback becomes really useful.
Yeah, bro, I can do that.
It works for you, Vivek.
Yeah.
Okay, so it works for one person. One is good. Karina, does it work for you? What's different? What's different between Vivek and Karina? It's set up exactly the same. Exactly the same. What? Let's just see if we can. Here, we'll become the super user. Okay, now I can do anything I want. It worked for you. So I'm looking at the Vivek stuff. Read, writable. There's the file. It works. That's no problem. And if I go into the exact same thing and look at the file. Well, Karina, I'll just do this for you. But if I have to do this for everybody, I will. So I've just copied those files for you, so you have your own copy of it. I have no idea why it's working for some but not others. Anyways, we will proceed. If this isn't working for you with some other way, okay, it worked. We'll get you all figured out eventually. I need to distribute this assignment 7 to you. I've also put this file up on the course shell on Brightspace, so you can download it from there. Any which way. Okay, let's try and persevere through here. So, assuming you made a copy of it, let me talk a little bit about what's going on in NumPy and Matplotlib. Okay, so first of all, so Jupyter is an environment where you're able to interact with among other things, Python, right? So as I said, you've got along here all your different files. If you click here, this is called the launcher. You can create new notebooks, which are just collections of code. You're also able to create, have a bit of an interactive editor. So if you were to do something like right-click on the background here, say new file, let's call it, let's rename it. Rename my program.py. Okay, you can open up a text editor here, x equals 1, y equals 3, print x plus y. And then you could open up a terminal, which again, file, new terminal, that would work, so that you could interactively set up Python. Oh, I have to save it. You have to remember to save. File, save Python file. Got to remember to save. My program, you can run it. And one of the advantages of this Jupyter Lab interface is you can do things like moving windows around. So you can have multiple things going on. So you can imagine an environment where you're typing in Python code and you're running it. So far, this is very similar to VS Code or some other integrated development environment you might have used. The real power in it comes in these things called notebooks. Notebooks are sort of like a way of having code and non-code things intermixed. Let me demo. I'm just going to close this so you can see a little bit more of it. Make it a little bit bigger so that we can see it on the screen. This is a notebook produced by a guy named Ryan Abernathy, who's a fellow scientist that I know in the United States. He wrote a lecture under a Creative Commons license, and so I'm going to use it here. What I want to talk about is NumPy and Matplotlib. I just want you to have the tools so you can follow along. When we're doing stuff in science, once you have Python as a language, as sort of a base, the next two most fundamental libraries that almost everything is built on is the library NumPy and the library Matplotlib. So NumPy, numerical Python, Matplotlib, a plotting library that is inspired by the MATLAB programming language. The way you bring in a library is to use import, but because NumPy is so commonly used, what we do is we almost always import it as a short form. So we say import NumPy as MP, and that brings into the environment the words NP. Oh, if you're completely new to notebooks, if I just hit enter, it enters inside the cell. To run a cell, what I would do is I would go up to the run menu, and you see here it says run selected shells, shift enter. So what we typically do is you have a cell, you go up to run selected cells, and you hit shift and you do it. But the shortcut is shift enter. So almost everyone gets in the habit very quickly of typing in a cell and then holding down shift and pressing enter. And this number will go from a 1 to a 2 to a 3 as things get executed. Okay, what happened when I did the import? Well, what happened is I brought in NP into the namespace. What's a namespace? These are all the things that we know about. They're basic built-in variables, okay? They're not that long. Some of the variables that are built in is exit. Remember how we talked about quitting out of Python? Well, that's a built-in functional. There's a few other ones like the name. Remember we talked about name before as being main if it was a script. That's a built-in variable. There is the built-in variable in and out. Those are actually just the contents of the cell and the output of the cell. And that's about it. There's very little in here. If I create a new variable, say x equals 6950, and I execute that, and I do a dir, you'll see now that there is a new variable in the namespace, x. Okay, and this is just everything that this current module knows about. This is what it knows exists. NP is its own namespace. If I go and I take a look at what's inside NumPy, do a dir on NumPy, you find more than a few things. Here are all the things that NumPy knows about. So there's some constants, there's some module level things, and then there's a bunch of functions. Adds, Amaxes, arctans, arrays, at leasts, Bartletts, Blackman filters, ceilings, complexes, cross products, diagonalization of matrices, and we're only up to the E's, okay? This library has everything you would normally expect to see in a numerical library. It's got all the functionality that you want for dealing with arrays, matrices, math. You can think of NumPy as the recommended math library for Python, right? On this system, I'm running NumPy version 1.19. And as you are beginning to learn it, the documentation is crucial. And so I put the link right here. Be aware this is where you go for the documentation. If you click on this and go to NumPy reference, what you're going to see is it'll open up a web page. And here is like the official canonical documentation of NumPy. And it says, this is the reference manual. This is the read the manual for everything. And if you're trying to look up some detail on it, you can look this in. You can look here. Now, the documentation is used so often that it's actually built into the help menu here of JupyterLab. And so if I go to help, you can see NumPy reference, and I click on NumPy reference, it'll actually will load this page as some documentation. It's the same information that's on this website. It just happens to be right in line. And so you can hide this towards the right so you can get to it and take a look at whenever you care to. Let me just zoom in so you can see more of this screen. Okay, so know that there is a documentation there. This is not the kind of documentation you read top to bottom, but you look at it as you're trying to understand what can be done. You want to do something with linear algebra, you look up linear algebra functions, and you'd be like, how do I do linear algebra? Or Fourier transforms, or whatever. Under the hood, NumPy is actually calling a lot of functions which date back or were originally implemented in Fortran. Fortran is a very fast historical language. It's still used in science lots, but it's got very good algorithms for doing a whole bunch of things in linear algebra, factoring matrices, calculating eigenvalues, inverting things, operations. And so NumPy provides you an interface between high-level Python language typing and lower-level applications like basic linear algebra subsystem or LAPACK, which is a Fortran library for doing linear algebra. Could be written in C, could be written in Fortran. It provides that interface so we don't need to worry about that kind of stuff. The core of NumPy is based on this data type called an ND array, an n-dimensional array. So an array is a sequence of things like a list, but NumPy understands the idea that arrays can have multiple dimensions. They can be matrices of rank 2 or rank 3. So the main thing to understand when you're working with NumPy is the fundamental data type is this thing called an ND array. So here's a representation of what these things look like. An ND array is in memory a little bit of header information that includes the data type, what's inside the array, and then just a sequence of a whole bunch of spots in memory where each thing is a particular scalar of that data type. Much better with an example. If I say NP array of 90210, I have created a NumPy array, an ND array with this data. Now, what's this data type? Because these things are each integers, in memory, each integer is storing a 64-bit integer. So that's the data type. Arrays have a concept of size and shape. This array has 1, 2, 3, 4, 5 elements in it. So if I say a.shape, I get a tuple back, which says, okay, this thing is a array of size 5, 5 comma nothing, because it's a one-dimensional array. The shape itself is a standard Python type, which is why we learned about lists and tuples. That's what the round brackets represent. Now, why is it a tuple? Because arrays can be multidimensional, right? The ND of ND array stands for n dimensions, 2D, 3D, 4D, 5D. So if I give it some data, which is a two-dimensional array, and one way of typing that out is just to say open list, first row, comma, second row. And I can say, you know what? I want you to treat each one of these things as a float. Now, this is a array of data type float 64. It means that every variable in memory is represented by a float 64, a floating point representation, and it has 2 columns and 4 rows. Now, these are just abstractions to be able to help us deal with these things. If we just type in A by itself, Jupyter or Python is going to give us a textual representation and say, hey, this is an array 90210. If I've got another array, it's going to render it in a way so that it sort of starts to look like a matrix. It's subtle, but in terms of memory management, when you're dealing with higher dimensional arrays, NumPy uses C-style indexing, which means that the outer level hierarchy is the first dimension, and the fastest varying dimension is the last dimension. So what does that mean? It means that in memory, the memory is ordered 5, 3, 1, 9, 9, 2, 3, 4. And that's how the array is stored in memory. There's another way of indexing stuff in Fortran. In Fortran, this same array would be indexed 5, 9, 3, 2, 1, 3, 9, 0. That has nothing to do with how NumPy understands it. It's how this array, which could be multidimensional, is actually stored as an array in memory, as a memory array all the way through. It's not an important issue, but if you're familiar with other languages, you may care. Okay, when we're creating arrays, we don't always just create them by hard coding a list. There's a number of NumPy functions which help us create arrays. All the functions within NumPy are typically np dot. Where does the np come from? Again, it comes from the fact that we said, I'm going to import NumPy as np. Okay, so np is in the namespace, is the namespace of all the NumPy functions, and there's a bunch of things. I can create an array of zeros, an array of ones, a full array, that is a 3x3 array where everything's equal to the value of pi, an array of ones that has the same shape as C, but it's filled with ones, an array which has the same shape as D, but it's filled with filled with zeros. Okay, what do these look like? Well, it's an array, a 9x9 array of zeros. What's D? D is a 3x6x3 array of complex numbers. So you could think of this as like a tensor, right? It's not just rows and columns, but it's IJK. It's got a first dimension, a second dimension, and then a third dimension. And so if you look at the shape of D, it has the structure 3, 6, 3 because it's a 3-dimensional array. E is a full array. What does full mean? It just means that it's the entire array. Oh, that's not what I'm expecting. Fill type. Oh, I overwrote it. That's the problem. E is a data type, which is just filled with the value pi, right? It's a 3x3 array where there is pi's everywhere. So it's just created an array of, pi's. F is an array which has the same shape as C, but there's ones everywhere. So because C was a 9x9 array, this is a 1x1 array. G has the same shape as this array, where everything is a 0 in the same data type and the same shape. So to create arrays, what we typically do is we manipulate these basic structures, zeros, ones, i's, and we create arrays as we need to. The other kind of creation we may want to do is create a range, which is just a sequence. We've talked about the function range, right? And remember what range does is it gives us a sequence of numbers from something to something else, and we can have a starting point and an ending point. And remember, it always goes up to but not including the last number. This is a list. A list is a fundamental Python data type. An array is a different data type. And you don't use the range function, you use the NumPy A range or array range. And what that does is creates an array type all the way through. So the difference here, okay, this is a list which has the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is an array. They store the same data, but this is much more computationally efficient. This thing only requires enough bytes to store, well, each one of these data types 10 times. A list, you could think this is more of a linked list kind of data structure. It's not nearly as efficient or compact in memory. It's slower to iterate on. Arrays are a different data type. Like with range, you can have a start, a stop, and a step. The step can be any floating point number you want. So if you want to have an array that goes from 2 to 4, skipping by 0.25, well, there's 2, 2 and a quarter, 2 and a half, 2 and 3/4. And like with range, it goes up to but not including that number. So 2, 2.25, 2.5, 2.7, up to 3.75, because that's the last number, which is less than 4. If you actually want to go from 2 to 4, and you don't really care what the spacing is, but you want to have 20 numbers in that list, you would use linspace. Linspace says, what I want you to do is go from 2 to 4 and space them just so that there are 20 numbers all the way in there. And so this fraction might look a little bit odd to you, but what this is 1/19. If you're going from 2 to 4 and you want to have 20 numbers in the sequence, well, the 20 numbers have to have a space of 1/19 between them. I'll make this clearer in the sense that, let's say we were going to go from 2 to 4 with 4 spaces, okay? Well, the numbers are 2, 2 1/3, 3 1/3, and 4. Those are 4 numbers between 2 and 4 inclusive, and they're spaced equally. They're spaced 2/3 apart because that's the spacing. If you had 5 numbers in that list, then you're going to get a 2, 2.5, 3, 3.5, 4, because those are 5 numbers that are equally spaced. So depending what you're trying to achieve, if you're trying to achieve 2 to 4, and you want to include the number 4, you may want to use a linspace. If you want 2 to 4 and exclude that endpoint, you'd use an A range, whatever your application is. Linspace has a sibling called log space. You want the numbers 1 to 2, and you want 10 numbers in that range logarithmically separated. So 10, 12, 16, 21, 27, 35, 46. That's a bunch of logarithmically spaced numbers. So all of the things that you want. If you want to talk about 2-dimensional grids, what we can do is we can take a linspace in one dimension and a linspace in another dimension. So what is this going to do? It's going to create an array from -2 pi to +2 pi with 100 entries in the array. It's going to create another array, which is -pi to +pi with 50 spots in it. And then we're going to call a function called mesh grid to create an array, which is 2-dimensional. Okay. So this is going to create an array, which is a 50 by 100 array. So let me just show you what XX looks like. XX has 50 rows, 1, 2, 3, ... 48, 49, 50. And what it's doing is across the dimension of the row, the numbers are going from -pi, 2 pi. See the -6.28, -6.156, -6, all the way up to ... 2 pi. every row is the same because this is just the x coordinate. In contrast, in y, the y coordinate starts off, so everything in this top row starts off as y equals minus pi, and every row increases so to y minus 3.01, y equals minus 2.88, all the way up to 3.5. So now the y dimension, the rows are all the same, they're all the same coordinates. And what this gives us, x and y, is a pair of coordinates that we can evaluate functions on. Okay, so you've got to be able to create an array. And once you've created an array, you can do stuff with it. What can you do with it? Well, you can index it. You can pick out a certain element out of it. So considering this array XX, I can say, you know what? I want the point at position 0, 0. First row, first column. I want the last row, last column. I want the fourth row, fifth last column. And these are just different values inside this 50 by 50 array. If you want an entire row or an entire column, you're allowed to do that. XX of 0 will give you an entire row. XX colon, comma 1 will give you an entire column. Remember, this is a 50 by 100 array. That's its dimension. That's its shape. Colon represents all of the rows. Pick out a certain column. Colons also can be used for subsetting. So if I had an array that was 50 by 100, I can say, give me all the values between row 10 up to but not including from row 3 up to but not including row 10, and from column 30 up to not including row 40. Okay, and it's going to be a subset of that whole array. Again, dot shape is going to show me the whole thing. If I leave that off, I actually display it. So here are all the entries in the array for XX in this subset from those rows. It's a little piece of that array. G, well, we talked about G already. That's so thing. There are lots of ways of indexing in arrays, and you can read about those in the documentation. An array, you can do complex searching. You can say, you know what, give me all the values where XX is less than 0, and then anywhere that XX is less than 0, give me back YY where that condition is true. Right? So let me show you what this would mean. IDX is going to just be an array of trues and falses wherever XX is less than or equal to 0. And what you can do is you can choose that, use that array to, YY, to index another thing, giving me back all the particular values of this other array where XX was less than 0. You can always take an array at any time. You can take any array, and even though it's two-dimensional, unwrap it. Because in memory, and this is the point of these n-dimensional arrays, they're not actually stored as two-dimensional or three-dimensional things. They're actually stored in memory as one memory address after the other in a long line. So even though we're looking at this thing and we see it having a two-dimensional structure, it's actually just stored in memory. These 10 numbers, then these 10 numbers, then these 10 numbers. NumPy can, without any effort, ravel them. You can think of raveling and unraveling. Unraveling is untangling something. Raveling is just give me the data as a sequence. So this array is just XX. Okay, what do we do with these things? I've got arrays. I can look at them. The point, the value of them is I can use them to do math. Okay, so let's say I had this function. XX and YY represent a grid of X and a grid of Y. And I can take a look at XX, YY and do a piece of math like this in one go. The power of this, if you're familiar with MATLAB, you may be not as impressed. But if you're not coming from a background with MATLAB, if you're just familiar with Java, JavaScript, C++, doing this piece of code would normally require 2 loops. And what we've done is we have just evaluated the sine of X times the cosine of a half of Y everywhere. You can visualize it with just numbers. But if I use Matplotlib, then I can make a plot of that data. Okay, Matplotlib is the standard toolkit we use, and you can see what's happened is we visualized every little square of this image as a picture. So we very quickly made a plot of the function sine x cosine of y. It's this ability to very quickly give a mathematical formula, which is one of the appeals of a language, a library like NumPy. As I said, if you're familiar with MATLAB, this is one of the reasons that MATLAB is loved so much as well. This vectorized operation. The point is, in NumPy, these functions are applied element by element to the entire array. Okay, you don't have to do it this way, right? There is a math library built into Python. Okay, and I can say math sine of, I don't know, 23, and I can evaluate that. But if I try and say sine of xx, it's going to say only size 1 arrays can be converted to Python scalars. So without NumPy, what you would have to do is something the equivalent of for I in 50, for j in 100, ff of I comma j equals math of I comma j times math cos 0.5 times I plus j. Okay. I lost a bracket. Int is not interval. Oh, in range of 50. Range of 100. F. Okay. Works, but very, very, very slow. Okay. This is how you would write this command in lower level languages. Lower levels languages that were further down a hierarchy of languages. What NumPy is doing is it's internally converting this line of code into something which in C is effectively this, but it's not being run as Python. It's being run as a lower level language. So this runs much, much faster. I don't know if we're going to talk. We might talk about it later, but I'll do it right now. When you're working in Jupyter, if you put a colon time it at the top, what it will do is run this cell a number of times and figure out how much the average time it takes to run this cell. Okay, so what it did is it did this 100 times, calculating the value. It ran this 100 times, calculated the average time, and then it did that 7 times again. So it actually ran this piece of code 700 times and estimated that every time I ran it, it took about 3.79 milliseconds, plus or minus 48 microseconds, to execute this code. Okay, and if you know much about computers, 3.79 milliseconds is actually a lot of time in computer land. In contrast, if I run this program, it's going to run it a bunch of times to come up with an estimate of how long this code runs. But you'll see that this is running its loop in 109 microseconds. Okay, so compare 3.79 milliseconds to 100 microseconds. And that's the speed up you're getting when you're using a library like NumPy. Now, if you were to write this in a language like C or Fortran, you might be able to get this number down to 50 microseconds. But the speed up from 3,790 microseconds to 100 microseconds, that 30-fold speed up, is very easy when you're already working in Python. To go from here down to, say, 50 or 60 microseconds, which you could if you did in a lower level language like a C or a Fortran, or even a really low language like assembly, you'd be able to shave this down a bit, but I don't think you'd be able to shave it down by a factor of 30. So this is the power of working with a library like Fortran, NumPy, is it gives you close to compiled languages speed with great expressiveness and less keystrokes all the way on. Incidentally, when we're talking about languages, I'm always thinking of some sort of hierarchy of programming languages, right? You can think about, and I don't know, it doesn't really matter. Someone's going to give me a picture. This is good. Here is somebody's visualization of it, right? You can think of your program as being at a high level language like C, assembly language, which is the moves and adds, machine language, which runs on the hardware, right? You can think about code living at one of these levels. This is the actual binary ons and offs. This is the level which we coded in. But within these high level languages, we sometimes talk about a hierarchy of languages. I don't know. I don't know how good this image is going to be. Let's pick this one. There's an old figure. Just waiting for it to go. Okay, right. You can think about machine language or assembly language, these being low. High-level languages, when they think about high-level languages, typically people are talking about C and Fortran and Pascal. Those are actually high-level languages. Above that are even higher order languages. Things like, well, C++ would be a bit higher order. Rust, Swift would be higher order compiled languages. MATLAB, R, Python would even still be higher level because they abstract more of the things. The further away you are from the hardware, it tends to be the slower the program runs, but also the faster it is to type. And so there's a trade-off in these programming languages between how much work you and I need to do as humans and how much work the computer needs to do. Python works at a fairly high level, but it's able to do function calls into these lower level, high level languages like C and Fortran to give it a bit of a performance boost. And there's other ways of hierarchying languages, declarative and imperative and whatever, but just that idea of a high level or a low level language. Okay, so NumPy is much, much faster. You can visualize arrays just by doing a plot of them. Okay, let's play with these arrays. Arrays are just things that live in memory. Okay, so we've got an array sitting in memory. F is the array. I told you already that you can visualize it. You can do things to arrays that you normally would want to do. You can take what's called the transpose. So an array is a data type. Remember we talked about types? It is, not G. It is a data type inside the NumPy world. You can ask, well, what can I do with an array? Well, here's all the things you can do with arrays. You can add them, you can multiply them, but you've also got a number of methods, including a transpose. And one of those methods is the transpose right here, which has a short form in the sense that there's the T. If you take an array f.t, it gives you back the transpose of that array. If you want to just visualize this, well, if I take an array and give me a transpose, what I'm doing is I'm taking this picture and flipping it so it looks like this. So I very quickly can start to manipulate arrays, and arrays could represent maybe images, and do some manipulations on it. In fact, I can reshape an array, rows and columns. I can consider it anything I want. Now, if I try and reshape this array into a 8x9 array, it's going to give me a value error. It's going to say, this array has 5,000 numbers. I can't force 5,000 numbers into an 8x9 array. It doesn't fit. However, you can force 5,000 numbers into an array which is 200 by 25, because 200 times 25 is 5,000. Now, I don't know if you'd want to do that, because what you're doing is reorganizing in memory how this array is structured. But you can. It will look really weird, but you're allowed to do that. You can break up this array however you want. So you can go and you can take an array and you can tile it into a bunch of pieces. So you can look up the documentation of np.tile, and what that's going to do is take this fundamental array, this basic building block, okay, and it's going to make copies of it into a whole bunch of pieces, right? It's going to make it into a 6x1 array. It becomes a tile, some subset of this overall structure, and it's going to get replicated again and again and again. So I think, yeah, the basic unit is this 50 by 100. Remember the original array? plit.color mesh of f, p color mesh of f, was an array that went from 0 to 50 and from 0 to 100. NP tile is taking that array and making multiple copies of it. So you're actually getting 1 copy, 2 copies, 3 copies, 4 copies, and tiling that pattern again and again and again. So you can create quite complicated arrays from these basic operations. NumPy out of the box understands how to take arrays that are the same size and do operations on them. So if I take an array like FF, okay, and I add it to another array like FF, not FF, F plus F, okay, what it's going to do is it's going to do pairwise operations. So for every element in the array, it's going to go figure out what it would be if it multiplied by itself. So if I did a plit.p color mesh, you take a look at it, right? All I'm doing here is doubling the field. Okay, let's be a bit fancier. NP sign of F. Yeah, I don't know what that's going to look like. That's boring. 10. Also, square root. No, square root's bad. Sure, we'll do square root because you can't take the square root of a negative number. Okay, I've taken the square root of this function. And so anytime the function was positive, oh, here, I'll do square root plus absolute value of F. There we go. There we go. There's the square root of the absolute value of the function when you add it to itself. So you're getting some canceling. The point is what it's doing is applying it element-wise. Every array value is getting updated by the corresponding array somewhere else. So if we have an array like NP range, let's say 10. Okay, I'll just show you what A looks like. Oh, not A range. A range. And I've got another array file, which is empty. Let's just do it. Hard code it. 1, 1, 1. Oh, I know. We'll use ones. Ones. Is that? Yeah. So there is an array of ones, 10 ones. There is an array of the numbers 1 through 10. If I say A plus B, can you see that what's happened is 0 plus 1 equals 1. 1 plus 1 equals 2. 2 times 2 equals 3. 3 times 3 equals 1. So this idea is what NumPy does out of the box. But there's something else that's going on. NumPy understands the idea of broadcasting. Okay, what is broadcasting? So this is something that works underneath the hood. And when it works, you're very happy. And when it doesn't work, you dig into this. What it does is it accepts the idea that when you've got an array, you can manipulate it together basically as rows and columns. So if you've got, let me think through it this way. This is the way we've been talking about it so far. You've got an array, and an array gives you an array plus an array gives you an array. So the thought here is if you've got 2 arrays that are 3 by 3, what they're going to do is sum pairwise every point to every point. When you have, and there's nothing magical going on. That's just sort of the normal element to element manipulation. If you've got an array which is 4 rows by 3 columns, and you try and add it to an array which is 1 row by 3 columns, what NumPy will do automatically is say, hold on, I think what you mean is since this function has 4 rows and this one only has 1 row, how about I just pretend that this data actually has 4 rows, but they're all the same. So this is called broadcasting, where this 1 row is being broadcasted across all these different dimensions. And when I do that, what happens is it's like adding the row 0, 1, 2 to each and every row. So 0, 0, 0 becomes 0, 1, 2, 10, 10, 10 becomes 10, 11, 12, 20, 20, 20 becomes 20, 21, 22. If I have rows and columns, you can't add those together natively, right? There's no obvious way of doing it. So what you can do is use broadcasting rules, and it says, oh, you don't have the right number of columns. Let me just create new columns for you, broadcast into different columns. You don't have the right number of rows. Let me broadcast that. And then I can add those two things together. And so what it's doing is it's copying all the way through. So let me demonstrate. Okay. So let's say you have an array F. F is 50 by 100. X is 100 by nothing. So it's 100 rows, no columns. It makes sense to say, what is F times X? Because broadcasting rules kick in. So even though X is not a two-dimensional array, what happens is X gets broadcasted, turns into the two-dimensional equivalent, and then the multiplication can occur. And so you're able to get a solution, P color mesh of G. So here what we've done is we've multiplied this function by X, and broadcasting rules kicked in. If I want to multiply this function by Y, it's a little bit subtle, because as given, the shape of X and the shape of Y are both the same. Unlike in a language like MATLAB, vectors of one dimension, it's not really clear that this is a number of rows and this is a number of columns. If you want to multiply an array, which is 50 by 100, by an array which is a 50 columns, what you need to do first is you need to reorient this array so that it is a column axis. Let me just show you what I mean by that. Y.shape. If I say y call np.new axis, you see that now it's a 50 by 1 array. So it's a column array, and that can be manipulated. Fundamentally, this is just a transpose of one-dimensional axis, but you do need to care about it in terms of broadcasting things together. So this has dimensions of 50, 1. This has dimensions of, or 1, 50. This has dimensions of 50 times 100. Multiplication works in a broadcast sense, and so you're able to multiply this in the vertical. Anyways, broadcasting kicks in. The way that I end up using it the most is if I have an array, right? There is a boring array, and I do something like that to it. This has dimensions 10. This has dimensions of 0, right? It has no rank. Broadcasting rules kick in, and so what happens is that 4 gets applied to each and every element all the way through. That's broadcasting as well in the simplest sort of situation. You got a bunch of reduction operators. You can do a sum. So it knows how to take sums of things. It knows how to take means of things, take standard deviations of things, right? Basic operation you care about. Now, again, this array is two-dimensional, okay? So you can visualize it with plot.p color mesh of G. And if I want to talk about the average value over all the grid cells, that's what this is giving me. This is the sum over all the grid cells, but it's a two-dimensional thing. So it's possible what you really want to look at is the average only along an axis. Like imagine taking every row in this and taking the average. Well, that would be the average over all values of, well, let me just make sure I get this right. You can take the average over either the first axis or the second axis. 0 is the first axis, 1 is the second axis. So this is the average over all of all the different y's. This is the average over all the different x's. So what you can do is you can take those averages and figure out that what you're looking at here. So again, x is the x coordinate. Remember, the x coordinate is in this direction. There's 100 of them. The average is, you're averaging over y. It's negative, averaging over y. It's positive, averaging over y. It's 0. It's positive. It's negative. So you're looking at this plot. If I did a plot of the average in y, right, what I'm going to do is I'm going to plot on the horizontal axis the value, and on the vertical axis, I'm going to plot y, because this is the average in y. This is the average in x as a function of y. Okay, how do these things all get put together? Well, here's a function. Here is its average in one direction. Here's its average in another direction. how would we put these tools together? We may want to use Matplotlib to organize these things so we can display them as one go. Like with NumPy, the documentation for Matplotlib is actually built right in here. So you can leave that open and to the side. And if you wanted to figure out a way of visualizing it, you could go to the examples and you could try and find an example of some time where different plots have been put together. Specifically, for this kind of data, we're looking for a plot like this kind of idea. You see, it's got a two-dimensional image and then did something on the top and did something on the side. Well, how is that actually done? Maybe what I want to do is have this image in the middle, this image on the top, and this image on the side. Well, I could go and I could take a look at this example, and it's going to show me with some documentation how this works. And what you do in the code is you've got this idea of well, here we go. These different axes. So a figure is the general idea of the image, and you can add axes on the top and add axes on the right, and then plot things in these three axes. So this is one way of solving it. Another way of solving it is use something called a grid spec, a grid specifier, where what you do is you use a function called grid spec, which basically says, I want to think about this as having three parts, a first part, a second part, and a third part, and I can put those in. There's 2 Jupyter notebooks that give you that example, or a Python script that gives you that example. There is ways of reworking this to produce something. In fact, that's what I've got down here. I have a third way of doing it. There's a function called subplot to grid. Well, what that's doing is giving me an empty figure, an empty background, and then saying, well, what I want is I want an axis. I want a grid, some axis I can plot on. Imagine this is a 6x6 unit, as in 1, 2, 3, 4, 5, 6 horizontal, 1, 2, 3, 4, 5, 6 vertical. Give me the 0 to 1 location of that and 5 columns. And then give me the 1, 0 location of that and give me 5 rows. And what that's doing is identifying these different subfigures. Then what I can do is I can plot, not with PLT, but each one of these axes can have a different plot. So on axis 1, I can plot this graph right here. On axis 2, this thing, I can plot this graph. And on axis 3, which I may want to call this guy right here, I can plot the entire image. And so here's an example of how this would all be put together with Matplotlib. So you see how we're able to start to get much more complicated graphs. We're building these things up bit by bit. Now, how am I going to learn that I'm supposed to use subplot to grid, or learn grid spec, or learn add subplot-lib? How am I supposed to learn this stuff? Well, this is where the documentation comes in. Okay, there is a reference. So sometimes what you can do is you can go to the documentation, and if you have a lot of time, you could just browse through it. I don't find the documentation for Matplotlib to be something you should read. I find the examples to be really useful. So you could just go to the examples and be like, I'm looking for a plot which is something like, and then you scroll through and you're like, I need one that does, what do I need to do? I need to change the axis label. So I need to find something where they're telling me what I can do with axis labels. So you'd go through and you try and find some example that talked about labels, aligning labels. So that's sort of cool. Axis demos, axis props, axis label position. Okay, well, that's sort of cool. How do I actually modify where the axis label occurs? Well, here it is. This is how you create labels, and this is how you place where they're supposed to be. So you learn how to use the library by looking at examples. That's one great way of doing it. And the other great way is tutorials. Okay. There are lots of tutorials, but the Matplotlib tutorials that are in here are actually pretty good. I would encourage you to take a moment, an afternoon, an hour, I don't know, however much time you want to spend on it, and work through some of these introductory tutorials to Matplotlib, so you just see what's possible, right? And you can see that there's a bunch of tutorials starting from really simple stuff more to advanced stuff. Take as much of this as you like. I would just start with the very first one, usage guide, and be like, okay, what can I do with this plotting package? Okay. And the very first thing it says is how we start all plotting packages is we use this introduction, and then it walks you through some basic examples. And this is actually what I started with showing you, was a zigzag sort of list. And it just walks you through how Matplotlib thinks about a figure. Matplotlib thinks about figures as built up into lines, markers, axes, figures, legends, ticks, labels. So these are the language that it uses in this idea. And it walks you through what it means by a figure or an axis or an artist. And it's not long, but just by going through the examples, you're like, okay, I think I understand how Matplotlib understands what this is all about. And once you've done that, you may choose to go to a slightly more advanced tutorial and be like, okay, let's look at some sample plots. And if you figured out how to make the image you're looking for, you're done. You don't need to do any more. But as you come back to it, there may be more things that you're saying, I wish it could do a plot like this. Because you know what? I want to make this plot myself. I want to make this plot the day I realized I could bacon whenever I wanted, and your health goes down. Because you know what? I like those XKCD examples. Well, what you could do is you could grab the sample, put it in there, and it will tell you if there's any errors. What's the error? Has no attribute right. X.spines. Okay, so there's two issues here. One is I need some fonts. I don't have fonts on here. Oh, well, that's too bad. I was going for a fun one. You could play around with it, right? And the idea is just to try the demos to get a sense of what these things do. And if you want to, you can go into more deep stuff, but I don't need you to for the purpose of this course. But my expectation is you've at least browsed through the examples, you've browsed the tutorial, so you can see what's possible in this graphing library. Later on in the course, we talked about the project earlier in the week. I'm going to ask you to make some plots with Matplotlib. The idea is, the intention is to go through the tutorial, go through the example, and be like, hey, that's a cool plot. I wonder if I can make that plot with my own data set. And we'll talk about that later. But do explore the documentation. Okay, so that's the basic libraries. NumPy gives you arrays. Matplotlib lets you do visualizations, make charts and graphs and plots of those arrays. How does this all get used in practice? Well, in practice, what you do is you got some data. So if you're a scientist, if you're an oceanographer, I'm a physical oceanographer, the Department of Physics and Physical Oceanography, we look at instrumentation data. So there is data out there. So here, out there in the world on some website is the data from an instrument called an Argo. An Argo is just a sensor we throw in the ocean. It lives in the ocean for 3 or 4 years, and it bobs up and it bobs down, measuring temperature whenever it bobs up and bobs down. So this data is somewhere on the web. I can go and download that file. This is sort of cool. In Jupyter, if you put an exclamation mark, what you can do is type in any command you would normally type in a terminal. wget is a command inside a terminal to go and get a file from the web and download it. So if I do $wget, I will download a file. And now in my directory is an Argo float this file. I can see that in 2 ways. One is I could take a look at the terminal, but I also could just open this up and I can see now that I've got an NPZ file. Now, an NPZ file is not something it knows how to view. It's not a standardized file format that's an image. We have to load that file. Well, NPZ basically stands for compressed NumPy files. It's a standard way of saving and reading a NumPy file. And the way you do it is you load it in. Okay. So when I say np.load, I take a NumPy file and I load it in to memory. Okay. So that's what it is. This is what this thing is. It's a handler for an NPZ file. It's just some file format. The data, what's inside of these things, it's sorted by a bunch of keys. And so if you take data.keys and display as a list, you'll see that inside this file is actually a number of arrays. And so what you can think about data is it's a dictionary. And it's a dictionary where each one of these variables can be brought out and you can take a look at it. So data T, this is the T variable. I can pull that out of this data structure. I could pull out the S data, which let's pick up the pressure data. P is pressure, or S is salinity. Okay, and each one of those is an array that's now in memory. T by itself will just give you a textual version of that, which may not have much meaning to it. But we can start analyzing it. Maybe what we want to do is find out T represents temperature. So what's the coldest temperature that this instrument measured? Well, if I do T.min, we got some problems because there's times when the instrument failed or didn't produce a measurement. And so I've got some not on numbers. NaN stands for not a number. It's basically a concept within floating point representation, says invalid data. It's sort of like a none, but it's called a NaN, a not a number. What we can do is we can create what are called masked arrays to hide certain values from the calculations. A masked array, if I have a masked array of 1, 2, 3, 4, 5, anything where the mask is on, these things get ignored. So what happens with a masked array is you've got data, and then you've got this Boolean array that basically says ignore these values. So what does that do? It means that this array, when I ask for the mean of it, I'm not taking the average of 1, 2, 3, 4, 5. I'm only going to take the average of values that are not masked, not hidden. Okay, let's see how this would work. There is, under the NumPy masked array module, a tool which says mask invalid values. So what does that do? It takes an array, finds anything which is a NaN or an infinity, masks it, and now that mask I can use to take the average value. So the average temperature of all of this data, independent, ignoring all the NaNs, is 11 degrees. That's how it works. So this will give you an example of how you deal with missing data in NumPy, right? It's a masked array. The masked array ignores it. And now what this allows us to do is more complicated visualizations, which is something like a TS plot. This is a temperature salinity plot as a function of pressure in the ocean. And if you take a snapshot of all the salt content and all the temperature in the ocean, what you're going to find is the general trend is when the density is very, very high, or the pressure is very, very high near the bottom, the water is colder, and it is, well, it is colder as you go deeper. That's not too surprising. And actually, as you get towards the surface where the pressure is less, the salt content goes up a bit, which I'm a bit surprised by. That's not what I was expecting in this data set. Anyways, it's a visualization. Okay, so this notebook has been sort of just a little bit of an introduction to a little bit of NumPy and a little bit of MATLAB. And the intent is browse the documentation and learn a little bit about it. In terms of a deliverable, okay, what do you want me to do with this? I'll do the same thing. What I've done is I pushed up here something called assignment 7. I will copy it and I will paste it. Paste. Okay. This file has a bunch of questions that I want you, as your assignment number 7, here, let me just close all these up. I don't know if it's working or not. No, discard, discard. It's loading, it's loading, it's loading, it's loading. Okay, to analyze some Argo data. And again, an Argo, okay, an Argo float is a piece of oceanographic equipment. What happens is people throw them off the sides of boats. Okay, there are some people throwing an Argo. That thing's an Argo off the side of a boat. Okay, they toss it overboard and it bobs along. And what it does is it drifts in the ocean down at about 1 kilometer down, and every 10 days it dives down to 2,000 meters, shoots up to the surface, transmits this information to a satellite, and then dives back down and waits. And it lives there for about 3 or 4 years. And there are thousands of these Argo floats all around the world collecting information. So that's the data we're looking at. So what I want you to do is analyze some Argo float data. Okay, so specifically, what is the command required to load or import in the NumPy library? What is the command required to download some data? Take a look at this one for an example of how to do this. Try and extract out some data, masking out invalid data. Make a plot. Make a plot of temperature versus column levels, basically, how temperature and salinity and pressure change with depth. Okay, compute some means and standard deviations, plot some error bars. Okay, so that's the first bit. And the second bit is I want you to write an algorithm that's matrix multiplication, as in like the matrix A times the matrix B gives you the matrix C, right? You do this matrix multiplication. If you've totally forgotten what matrix multiplication is, take a look at Wikipedia. And what I want you to do is write a bit of Python code that actually implements a function called myMatrixMultiply that does matrix multiplication of two things. So what am I looking for here? Def myMatrixMultiply A, comma B, return, okay, code to matrix multiply, return C. Okay, so whatever you need to write to make this work, and it probably is going to be in range something for J, in range something, whatever you need for a matrix multiply, so that this code works in a pure Python non-NumPy sort of way. You're allowed to use NumPy arrays for A and for B, but the idea is to do that. And then what you do is I want you to time this function. So we talked about time it. I want you to figure out how long this function takes to run for an array which is 100 by 100. Then do it with a NumPy version of matrix multiplication and figure out how long it's going to take for 100 by 100, 1,000 by 1,000, 10,000 by 10,000, and try and just estimate how slow this would have been if you wrote it in Python. Anyways, I think if you do that, you'll have been exposed to enough NumPy and enough Matplotlib to carry us forward. I didn't give you a break today because I was just trying to wrap up so that maybe we could be done. But I'll close here with a call for questions. Is there any questions about NumPy, Matplotlib, or Jupyter that we should talk about now?
Hello, Professor.
Hello.
Can you hear me?
Yes, I can.
So my question is, the assignment, should you do it this platform, right? You are showing right now.
Whatever you like. If you want to use my platform that I've set up for you, you can go ahead. If you'd prefer to use your own environment because you've got this set up or you've tried to do it, like the actual file, okay, is available on this platform, but I've also thrown it up on here. Okay, how do I log in? Is it going to let me log in? It won't let me log in. Trust me when I say that it's up on as assignment 7. It's a file, right? So it's an IPYNB file. You have to download that, open it up, and however you want to do it. And the instructions here are you should hand this thing into your private GitHub repository, CMSC6950 assignments. Do you remember for assignment 2, I had you create this repository? Submit it to me by committing this file into it. On this computer, you've got access to a terminal, right? So I can go new terminal. I can go ahead and go over to GitHub. github.com. I've got some data here. I won't do mine. I will just here. I'll do something that's public. I'll pick someone's. Oh, the branch has been renamed. I just need some code. I want like a little repository, not a big repository. Oh, okay. Well, fine. We'll just do practical Python. Okay. So for example, I can take this data, I can clone it, I can go back to my terminal, and even though this is on a remote machine, git clone. Right. I've now got on this computer. I'll refresh this practical Python. There's all my data, all my files. I can open it up, and now you're not going to do this for practical Python. You'll do it for your assignments. You will create a new notebook. Well, not a new notebook. You'll copy and paste this notebook into your directory, and then when you're all done, right? You'll have your whatever your directory is with make directory CMSC6950 assignments. Right. I'll just go in here. Right. You got this. You'll copy this file into, well, whatever it is. I just initialized that. That was dumb. That's not what I wanted. Hey, you get it. You copy the file in, you get add, you get commit, and submit it to me that way. Does that make sense, Arnab?
Yeah. So basically, you're saying that I can do it on my laptop.
Sure.
And using any platform I want. I can use.
As long as you've got on your laptop Jupyter, Matplotlib, and NumPy set up.
Okay, so I can use Anaconda distribution too.
Yeah, that's fine. You can use Anaconda. There's nothing special about it. Just as you know, if you've already got it set up, it's easy. But setting it up itself can be a bit of a challenge, and I didn't want anyone to be stuck at the setting it up part.
Yeah, Professor, I got it. Thank you.
Okay, no problem. Okay, I think I'm gonna stop it here. Normally we'd have a bit of a break, but then there'd only be about 10 minutes left. If you're like, oh, I want more, I would encourage you to just start going through some of the tutorials on Matplotlib. Make some plots. Be like, what can I do with this thing? How do I make cool pictures? How do I render things? Right? I don't know. That looks sort of cool. You got a bug with axes, right? Or take some of your own data that you're working with in whatever your field of expertise is, and try and make a Matplotlib rendering of it. Just play with it. See if it works as you expect. And then to confirm your understanding, there's an assignment. Okay. Thanks very much, everybody. Next week, I'd like to cover the libraries Pandas and SciPy. And I think that will give us all the background we need to be able to tackle some actual scientific workflows. And I'll introduce the project next week as well. Yeah, I think we're good. That's where I'm going with this. So have a great one, and we'll talk to you later. Hopefully that's clear. Hit me up on Slack if you got any additional questions. Cheers, all.